Hi everyone, hope you're doing well. This is a video to go over do now number 4 for the Regents review. And we're going to do a do now that has an inequality question and a piecewise question. Don't forget to post these on Google Classroom so you get credit for today's classwork. All right, here we go. You'll definitely need a ruler and a calculator for today's do now. So it says, graph the inequalities, state one point that satisfies both inequalities. All right, so I'm going to take those two. I'm going to transfer them down here. So we have 2y is less than 3x plus 4. And then we have y is greater than or equal to negative x minus 1. So we're going to divide everything by 2 to get this in slope-intercept form. Y is less than 3/2 x plus 2. We want to list our slope of 3/2, our y-intercept of 2. All right, so this is a less than symbol, so that means it's going to be a dotted line. It has no line underneath it. That's why it's dotted, because it means not equal to. And it's a less than, so it's going to be shade below. Okay, and then over here, this is already in slope-intercept form. So my slope is -1/1, and my y-intercept is also -1. Greater than or equal to, that means that it's going to be a solid line, and greater than is going to be shade above. Okay, let me just remind you, I guess I'll just write it down here. If you have a symbol like this or this, that's going to be your dotted. If you ever get a symbol like this one or this one, that is your solid. These ones are your shade below, and these would be your shade above. So that is what you have to know for to do this. All right, so I'm just going to do 1 box equals 1 unit to save time. And here we go. So we're going to begin at 2. So begin at the y-intercept, and I'm going to move up 3 and right 2. Up 3, right 2. And then go back here, down 3, left 2. All right, and it is going to be dotted, so make sure that I can tell it's dotted. And it's shade below. So we go to where the y-intercept is. Remember, the y-intercept is on the y-axis. So this is y-intercept is 2. I want to shade all the y values that are less than 2. So this would be like 3, 4, 5, 6, 7, and so on. So we want 1, 0, -1, everything like that. And you want to make nice horizontal lines just like this. You don't want to do art class shading. You want to see everything to be nice and neat. All right, so for the next one, we're going to begin at -1. And because it's a negative slope, we're going to move down, but still go to the right. So down 1, right 1, down 1, right 1. And go back to that y-intercept, up 1, left 1. Up 1, left 1, up 1, left 1. Okay, so this is going to be a solid line. So make a nice solid line. Don't forget your arrows on the ends. Okay. And this one, oh, I forgot to do my inequality. So 2y is less than 3x plus 4. And notice that I put the original. Okay, that's so important. Always want the original. And I'm going to write this. Original inequality must be inside the shaded area. Not touching the line. That's important because you're showing that everything in this section are the answers, not just what's touching the line. All right, so back to here, sorry. So we did our slope of y-intercept of -1, slope down 1, right 1. We made our solid line, now we're ready to shade, so shade above. So my y-intercept is -1. On the y-axis, I want all the numbers that are bigger than -1, and that would be up here. So now this time our shading is gonna go up here, nice and neat. Let's do our inequality now so I don't forget it. Okay, so let's see. We did our shading, everything looks good, and the only thing we need is our S for our solution set. Remember, that's where all the shadings intersect. That means anything from this section right here, I'm going to highlight it, even though on the Regents you would not be able to. Touch your graph, anything from that section is going to be an answer. So state one point that satisfies both inequalities, anything from here at all. So 1, 2, 3, 4, 5. I'm going to go 5, 5. Okay, and this is an answer because it is in the intersection of the two shaded regions. Okay. All right, so there's one more little quick thing I want to go over, and that's this right here, this point. Sometimes the Regents will ask you about the intersection, and they want to know if that would be a solution. So because you have one solid and one dotted, do you think it's a solution? Hopefully you said no, because dotted does not mean equal. So I'm going to write this over here, not an answer or not a solution point, because one line is dotted. Dotted means it is not equal to, okay, and it's called something, it's called a boundary line, so I'll write that, and just a boundary line. Therefore, that point would not satisfy both inequalities. Okay, they have to be both solid is when it's going to be equal. So both solid equals good. All right, so if they ever ask you, when they have something that is one solid and one dotted, and they ask you if this is the solution point, it's definitely no, because dotted means not equal, and they have to both be equal to satisfy both of them. It's just considered a boundary line. All right, so I think that one is done. If you even want to write that this is dotted over here to tell the person grading it, that would be perfect. All right, first one done. Now let's go to our second part of do now number 4. All right, so it says, given the function p of x, so we have a piecewise. We want to find the value of p of -2. We want to sketch the graph, and so find the value, sketch the graph. What value of x does it have an absolute maximum? Okay, so -2. So you have to see right here, this x value, where it lies. And the -2 would be right here. So we're going to use this one. So p of x equals x plus 3. P of -2 equals -2 plus 3, and P of -2 equals 1. So that is done. That's an evaluating. Okay, now we want to sketch the graph. So I have 1, 2, and 3 different piecewise, and I'm going to transfer all of them down here where I have some room. Okay, so the first one was P of x equals x plus 3, and that went from -5 less than or equal to x, which is less than -1. Then the second one was P of x equals x squared, went from -1 to 2. And then P of x equals -x plus 4, and that went from 2 to -5. All right, so for the first one, what's nice is too is that they gave us a compound, so we don't have to even think in our calculators where it's going to be. So this is a line, so you can either show the work by doing the slope and the y-intercept. I think it's a little bit easier to do this as a table just because they tell me where to start and where to end. So -5, -4, -3, -2, and -1. So I'm going to go on the calculator. I'm going to go into y equals, I'm going to put x plus 3. Go to the table, and I want to go from -5 to -1. I'm just going to copy the answers. So -2, -1, 0, 1, and 2. Okay, and then make sure you have to worry about those dots, okay? So this one over here, this one has to be closed. That's because the less than or equal to. And then this one over here is going to be open because it's just less than. All right, so let's see. So one box equals 1 unit, and let's start plotting our points. So -5. -2, that was going to be our closed. -4, -1, -3, 0, -2, 1, and -1, 2. Remember, that was open. Okay, this is open. So make sure you connect the dots and make sure you have your equation. And then make sure you have your constraints on there. All right, first one's done. Next, x squared, we know it's going to be a quadratic, so there is no m and b. You can only do a table. But again, this one's not horrible. 1, 2, because it tells you where to start and where to end. Usually it doesn't, so you kind of have to just look at the domain and figure it out from there. Okay, so x squared. This one's kind of easy enough. You don't have to put in the calculator, but we'll do it anyway. Okay, so we're going to go from -1 to 2. And that's 1, 0, 1, 4. So 1, 0, 1, 4. Both of these have lines underneath it, so these are both going to be closed. So -1, 1, 0, 0, 1, 1, and 4, 4. So all of them are closed. We have our little portion of our parabola. So again, we just need an equation and make sure you put your constraints on there. Okay, done. Next, we have another m and b. So -1 over 1 y-intercept is 4. Or again, you could do the table, which I'm going to do the table again. 2, 3, 4, 5, because it's just a little bit easier, I think. -x plus 4. Going to go to the table. And we're going to go from 2 to 5. 2 to 5. So 2, 1, 0, and -1. And let's see, we have this is no line underneath, so that's going to be open. And this one is going to be closed. So 2, 2 we said was open. 3, 1. No, wait, that's not right. Here's 2, 2. There's 2, 2. 3, 1, 4, 0, and 5, -1. Okay, connect those dots. Make sure you put the equation on the line and the constraint. It's very important because you're showing what section or what piece of the graph you're keeping. Remember, that's why it's called piecewise. That is not a very good straight line, sorry. Okay, and then notice, by the way, that here you had the same numbers, but one was less than, one was less than or equal to. Here you had the same numbers. One was less than or equal to, one was not. You can only have one open and one closed, or it's not a function, okay? If both of these were closed and I made a vertical line, it would go through 2 dots, and that's not a function. So that's not, that they would never have that, okay? All right, so let me remind you, this or this was open, and then anything with a line underneath it is closed, so that's good to know. For here, if you have one open and one closed ever, you guys probably remember, it is closed dots, okay? So one of each would be closed. If you have one open and one closed, you would close it. All right, so I think everything is graphed. So at what value x in the domain is absolute max? Okay, so absolute maximum, that's just the highest y value. So highest y value, and this one does not have to be a turning point. So what is my highest point on the graph? That's this right here. And what is that x value? That's x equals 2. So since we're talking about absolute maximum, I'll just remind you about relative max and min. Relative max and min has to be a turning point. Has to be a turning point. Okay, I know they didn't ask for it, but it's a good time for me to be able to review. And remember, you can actually check these in the calculator if you want. You have to just make sure that you're putting the function part in parentheses. And then also, because these are compounds, careful, you have to do one this way and one this way. One here, one here, one here, one here. So this is really -5 is less than or equal to x, and then x is less than -1. And then to get these symbols, don't forget, you press second and then math. All right, so I'm going to really quickly right now do that for you, at least as quick as I can. So open parentheses, x plus 3, and then we have -5. Second math is less than or equal to x. Close parentheses, another open parentheses, x is second math less than -1. Okay, first one's done. Next one in parentheses, x squared, and then -1 is less than or equal to x, and then x, second math, is less than or equal to 2. And then last one, parentheses, -x plus 4, another parentheses, second math, less than x, and then x is less than or equal to 5. And hopefully when I press graph, all right, so it's still with my scatter plots. So I want to press zoom and standard. Zoom 6 is going to get it back to normal. And then it's going to graph what we have there. So you have, there's your straight line. Now it's going to graph the little piece of the parabola, and then it will graph that right there. So yeah, that's just a way to remind you of how to graph it on the calculator. I think that's it. So this is day 4. So again, make sure you post this on Google Classroom for me so you get credit for the classwork. And if you have any questions at all, let me know. If not, this is all going to be really, really good review for you for now and for next year. All right, have a great day. Bye.